Okay, so as you can see, I'm not Edson, I'm Jakub. I'm going to cover a similar subject. Edson has delayed flight, so he will, we've exchanged slots, so he'll be talking in the second room in 2 hours probably. So yeah, what I'm going to cover is to tell a little bit about what happens when you already deployed microservices into production. So I'm going to talk about the consequences of the actions we are taking. Okay, so a little bit about me. So I work on a daily basis as a co-founder of the Devskiller platform. It's a platform that allows or brings the functionality of assessing programming skills in an online nice tests. I'm also run a training for the Bottega company. I'm a program committee member of this conference, and I'm a co-author of the Spring Cloud Contract Framework that we'll cover later. You have my Twitter handle here, so if you have any questions or any follow-up after the presentation, please tweet me. So do I know what I will be talking about? So that's the report for the SLA of our platform. As you can see, it runs continuously without any outages. And how we can do that and how we achieve such SLA, that's the subject for my talk. And paraphrasing one of the Polish prime ministers, you can tell the real developers observing how they maintain know how they start. And I think that is crucial to remember that the software we are doing is not a software, it's a system. The difference between software and the system is that software is something that I've implemented, I've put it into a code repository, and that's all. But the system is something that needs to run, needs to be maintainable. I need to be able to analyze what's happening inside the running system. Okay, and developing software and developing system that is production ready, so two different kinds of stuff, and I'm going to cover those details in this talk. But at the beginning, I want to ask you one simple question. When you think about the microservices, what is the size that you think is right for the microservices? I know that the line of code is not the best measurement that it's available, but it's the easiest one to scale or size the microservices. So how many of you think that 100 lines of code is a good size for the microservices? Just raise your hands. Okay, 1,000 lines. Okay, 10,000 lines. Okay, and 100,000. Okay. So the most people has raised hand on 1,000 or 10,000. And I don't want to be a judge that will say, okay, so 1,000 is okay, 10,000 is not okay. But let's do some simple math. When we realize that just a single average enterprise application is around 500,000 lines of code. It's often much more. It's often 1 million, 2 million lines of code. But let's assume it's 500,000. So it means that when you realize that you want to split it into microservices where each microservice has 1,000 lines of code, it will bring 500 microservices. So splitting just one enterprise scale application gives us 500 microservices. And just to show you the scale, 500 microservices is the scale of the Netflix infrastructure, okay? So Netflix has around 500 microservices, and those microservices are maintained by 1,500 developers, okay? 1,500 developers are maintaining the 500 microservices. So can you imagine that one enterprise application is maintained by over 1,000 developers? It makes no sense. So we realize that 1,000 line, it's a bullshit, okay? So the microservices are not micro. It's the biggest lie about the microservices. These are macro services. So the 10,000 line of code is much better. It will give us, I don't know, 50 applications, okay? But it's still too much. We'll probably be able to split it into 20 applications, and that will be probably enough. So 20,000 lines of code, 50,000 lines of code, that's the proper size for the microservice, not this value. And why it happens? Because we want to keep our microservices business-oriented. So we are using the bounded context approach that is known from the domain-driven design to set the boundaries for the microservices, okay? So we don't want to keep the technical microservices, because for the technical stuff, we have libraries. I can include a jar that will generate a PDF or will export something to CSV file. I don't need to keep the up and running service that creates the PDF files. Why? Because I need to care about the communication, I need to care about the infrastructure, I need to care about the security, about the monitoring, deploying, pipelines, etc. There is a lot of overhead behind the single services, okay? So we want to limit the number of the services. We want to also limit the number of the communication outgoing and happening in our system, okay? Because this communication brings troubles. So when I can limit the communication, when all the business processing is done in a single application, that's what is cool in the monolith. When the monolith is up and running, everything works, because everything's happened in the boundary of the same JVM, okay? There is no such guarantee in a microservices when we are communicating over this TCP or UDP platforms, okay? So yes, we want to keep our microservices business-oriented inside a bounded context, because that's the proper boundary for this one. So why do we want to enter the microservices? Why do we want to, split the application to microservices? An answer is autonomy. I want to be able to autonomically deploy or upgrade my applications, okay? I don't want to coordinate releases that, okay, to release this feature, I must release this and this and this and this microservice. No, the feature is independent. It's closed in one single microservice, okay? So I want to be able to deploy those services autonomously. I finished my job. I don't need to wait for any other team. I'm just deploying and releasing my job into the production, okay? Of course, I'm not able to run any breaking changes, but that's something that we'll cover later, okay? Okay, so autonomy is cool and the independence is cool, but are we sure? The problem with independence is just the joint probability of independent events is equal to the product of their probabilities, okay? And why it's important? It's important because when you have we have a business process, okay? And this business process includes free microservices. So all free microservices must be up and running to finish this process. So imagine that each of the microservices has the availability of 99.8. So what's the final SLA? What's the SLA of this whole business process? It's 99.4, okay? Because I must multiply all those elements. And here I have just free microservices, but I'm not talking just about the applications. The applications are running on some VMs. These VMs are behind some firewalls. They are using some network interfaces, okay? And that's the problem, because when you realize that you have a 99.9 SLA, but you have 10 components included in your business process, it means that it's not more 99.9, it's 99, just 99, okay? It's order of magnitude less than we expected. And when we take a look at the availability versus downtime, then 90% availability, it means that we're accepting downtime of more than 2 hours per day. Okay, 99% means that we are accepting 14 minutes. Okay, so that's the shift from 14 minutes to over 2 hours, just because we need to communicate more than one service than before, okay? So in the monolith, if monolith were okay and it was 99, then we had a downtime of 14 minutes. When we split this monolith into something that is called the distributed monolith, so I have a microservices, but I must communicate all microservices at the same time to be able to finish the processing, that means I'm screwed, okay? So that's not the way how we want to work with microservices. Because what's important here is that the availability is related to something that is called depth of our system. Depth, so the number of the services I must communicate to finish the processing of some business process, okay? And it's synchronous depth, okay? So it works as long as you need to synchronously communicate with other services. So if you want to get better SLA in the distributed environment, you must remember to prefer the asynchronous communication. We need to use asynchronous communication every time we can, just to be able to split this business process into pieces, okay? Because then we care about the SLA of each piece, not about the whole process that will be bring us giant troubles in the distributed environment, especially in such distributed environment as microservices, when we have not dozens of microservices, but there are hundreds of services that needs to be up and running, okay? So remember about that, because I've seen many implementations of the microservices that were just distributed monoliths, and the SLA of those processes were like 50%, okay? You had like 50% chances that this process will finish correctly. Because even the single microservices that were done were blocking the whole platform. So that's not microservices. There is no independence between services. This is just a distributed monolith. So remember to use the asynchronous communications, don't use the transactions, and build the real independent microservices stuff, okay? So the next thing really important also is the quality. Because it's easier to achieve the quality of the communication in the monolith when we are communicating, invoking just the Java methods. I know that the API between modules is okay because I'm able to compile my application. So I know that when my application has built correctly and I have the artifact that I can deploy in the production, the APIs between modules are correct, right? Because if there will be any issues between modules, then Java-C will shout, hey, you cannot invoke this method because it's incorrect parameter, okay? But I don't have such information between my microservices. These are independent applications using independent build pipelines, etc. So how can I deal with this one? I can use DTOs. That's the best solution. Yes or not? No. Why? Because when you decide to use the DTO, shared DTOs, it means that you are building something that is similar to the canonical model. And now imagine the situation. I have two services. One is the repository service, and the second is build service, okay? And the build service is invoking the repository service and saying to you, hey, I want to get information for such project. And the project information, project object, contains an enum with the type of this project. And what is cool in this feature is that repository doesn't care about the project type at all. But it's the shared DTO. What happens when I send the JSON object to the repository with new project type that is not present in this enum value in the repository? 500, okay? I'm not able to deserialize this because there is no such enum value like Gradle. Sorry, you are not able to process that. Okay, but I don't care about the repository type. Okay, but it's present in the shared model. Okay? So I have a JSON that allows me to use the loosely coupled communication, but I'm using, behind this JSON, there is a shared DTO, shared model, What's the difference then between the binary communication? There is no difference. Okay? It's not loosely coupled communication. And it's impossible to do that without coordinated releases. And I don't want to use coordinated releases. So if you want to be able to deploy it autonomically, all microservices, you must prefer the loose coupling communication. So I'm reading only the fields that are important for me, okay? And I ignore anything else. So I'm not using the shared model anymore, okay? That's great. But that was the simplest way to achieve the quality of the communication. Because you know that this model will be able to, you will be able to consume this model, you will be able to consume this request because it's using the same object. And now I'm saying you, okay, so don't use shared objects. So how can I achieve the quality of the communication? So you can say that, yeah, let's use end-to-end test. But why do I want to limit end-to-end test? There are two problems with end-to-end test. First is that on the stage environment, the stage environment is really dynamic. I'm deploying everything all the time. I'm fixing stuff, I'm breaking stuff, and that's okay, because that's my staging environment. That's the first thing. Second thing, we'll talk later about using circuit breakers, about handling failures, etc. So how can you be sure that in the end-to-end test you are running, are you hitting the real microservice, or are you just using the circuit breaker or the fallback procedure? You have no idea, okay? So you don't know if the communication is working, or maybe you are just getting information from the cache, because caches and such things are normal in distributed environments. So the end-to-end test is nothing for me in the distributed environment. So how can I verify if the communication works if the microservices are able to collaborate without running end-to-end test? So another simple math comes to help. If I know that if A is equal to C and B is equal to C, then probably A is equal to B. That's something that we remember from the primary school, okay? And that's something that we use in the distributed environments, and it's called the consumer-driven contract. What does it mean? It means that I'm creating the contract of the communication between A and B. And now I'm verifying if A is following this contract, if B is following this contract. And if both sides of the contracts are okay, then probably A is able to talk with B. And we have created a tool that is called the Spring Cloud Contract. Marcin Grzejczak and Josh Long were talking about this one. And that's the tool that solved this problem. So we define a contract in some sample groovy DSL file, and then we do two things with this contract. First thing is that we generate the automatic tests for the server side. So if the contract says, okay, when you invoke the get method on a /calculate URL, you will get response status 200, and you will get such and such body. And what would we do with this contract? We generate the test that set up the server, hits the server with the get URL, request for the /calculate URL, and checks if server responded with the 200 and such body with such and such headers. If yes, then it means that that server is following the contract. So then I'm generating also the stubs or mocks for the client side. And the client is invoking, but not the real server, just a stub of this service with the get request for the /calculate URL. And if the client is able to eat this response from this stub, it will the same be able to consume the response from the normal service, okay? So we are checking both sides without integrating them. And that's something that we use as a replacement for the end-to-end test to verify if the communication works. So it's our version of the Java C. So it's distributed Java C for verifying the contracts. And it works for REST contracts, but as well it works for queues and for synchronous communication. So Kenny was talking in the morning about the Spring Cloud Stream, and of course that's also covered by this Spring Cloud contract stuff. Okay, so we know that the communication is okay. So let's go next. What does it mean that we need to design for failure? It means that there are two ways that we can go. First is something that is called the fail-safe, and the second is called the safe-to-fail. What is the fail-safe? It means that I want to prepare my system that it won't fail. Okay? There won't be a failure on the production. And that's something that will be good, but it doesn't work. Why? Because there will always be a failure. Madhu was talking about that. Okay? You can't avoid a failure at all. So you must prepare for the failure. Okay? Because if you won't prepare for the failure, there is 100% that you will fail very, very badly. Okay? In a moment that you don't want to fail at all. So what does it mean, safe to fail? It means that I know I will fail. So I'm doing everything to reduce the consequences of the fail. Okay? I don't want to pay for this fail too much. Okay? So what can I do to prepare myself for the failure? So the first thing is that I want to retry the communication. The first step of preparing myself for failure is that I know that some service can be unavailable. Why? Because those services are independent. Okay? The service A can be restarted, redeployed, or something like that, while the service B is still working and want to communicate with the service A. So the situation when I want to communicate with the service and the service is not available is normal. It happens on a daily basis. Okay? I'm not able to use something that is called the zero downtime deployment on any service because it brings additional costs, like maintaining the database schema. It's harder when you want to follow the zero downtime deployment principles. Okay? So the first thing is retry. You are trying to talk to this guy and he's not here? Okay, so try again in 5 seconds, in 10 seconds, in 15 seconds. Still no action? Okay. So what should I do if the service that I'm talking to is not available? And I need to get the response from this service. What can I do? There is nothing I can do because this service is unavailable. So I need to prepare myself for the situation when this service is just gone and I have no idea why, I have no idea when it will get back. Okay? What should I do right now? I need to prepare for the situation and use, for example, the circuit breaker. So I know that nothing happened. I just need to have the fallback. What's the fallback? It's just an emergency procedure. Okay? Imagine the situation that I'm hitting the, okay, so I'm running the e-commerce site and you want to order something from my site. And the business process tells me that if someone tries to order something, then I need to check the fraud system to check if it's not a fraud. But the fraud system is not available. So what can I do? There is a lot of things that I can do, okay? But what should I do in this moment? Should I process it or should I reject this? I have no idea. I, as a developer, it's not my responsibility to take care about such processes. I must go and ask the business side, dear business, what should I do if the fraud system is not available? Oh, it must be available all the time. That's what we pay for. Okay, I know, but let's assume that it's not available. Then you will get fired. Okay, but what's next? What should we do if the customer wants to get the product and it's not available? Okay, so then business start to think, okay, so if it's a new customer, then reject the order. If it's an existing customer and the value of the order is lower than $1,000, then accept it. And if not, then say that, okay, it will be verified manually, etc. And now, the situation when the fraud system is not available is not a problem for me anymore because I already know what I should do if this fraud service is not available. And of course, this knowledge is written in my source code. So in the fallback method, I know that, okay, so the fraud system is not available. I've tried 5 times with some back-off strategy, and it's not available. What should I do? Is it a new customer? Yes, so reject. Is it a new customer? No, it's existing customer. What's the value? Okay, it's just the if statement. I'm just implementing the simplified version of the fraud system on the client side. Okay, so client needs to know what need to do when the service is not available. Okay, so it's the smart client. The endpoint is smart. That's the major difference between the ESB architecture and the microservices architecture. In the ESB, the service bus was responsible for such actions, okay? And in microservices world, the endpoints are intelligent, they are smart, they know what to do when they are not able to communicate with particular services. So that's the another stuff. Also, the biggest difference between fail-safe and safe-to-fail is that in fail-safe, I try to test everything, so I want to be sure that the service that is going to production has no issues, okay? There are no bugs inside this service. But the problem with testing everything is that the tests that cover all business functionalities are really expensive. Also, there are a lot of false positives, like, hey, why the build is not passing? Are the tests okay? So is the problem with tests or the problem with implementation? Yeah, sorry, I forget to fix the tests. I've changed the implementation, but I forget about the tests. Okay, that's the problem. So what I'm trying to do, I'm trying to verify only the critical paths in my application, okay? So I'm checking if the critical functionalities are working. And what about the other functionalities, not the critical one? Nothing. If there will be a problem, then customer will use some, I don't know, issue tracking system to tell me, hey, there is a problem with such and such functionality. Okay, sorry, dear customer, I know that there is a problem. Now I need to fix it. The problem is that if I'm going to spend like 2 weeks on fixing this functionality, this customer won't be happy anymore. But if I will be able to fix this bug in 30 minutes, then it's not longer an issue. But how can I fix the bug in 30 minutes? It's almost impossible, okay? It depends, because when you decide to follow the continuous deployment strategy, it means that I'm deploying to production every day, okay? What's the hardest thing in fixing a bug is to find this bug in the code. Find a change that has introduced this bug, okay? If I need to find a bug in 3,000 commits, it takes me days. But how many commits did I introduce yesterday? 30, 40, 50, 10? Okay? And it's really easy to find a bug in 10 commits. Because usually the service that contains the bug, there is just one commit. And you see, okay, that's wrong, I need to change it. Okay? I'm fixing this one, I'm writing unit tests to cover this stuff. And I'm releasing it into the production. And as we are talking about the microservices that has, I don't know, 50,000 lines of code, I'm able to build the service in minutes, okay? At Devskiller, we have a deployment pipelines, and from the commit or push to the repository, we are able to finish deploying to the all instances on production in 15 minutes, sometimes in 20 minutes, okay? So the whole deployment pipeline, with building the application, verifying contracts, deploying to the stage, running end-to-end tests on the critical paths, and deploying into all instances on production takes like 15 minutes, okay? So we are able to solve bugs in 20, 30 minutes, and that's all. And thanks to this one, we can avoid testing everything, and we can rely on testing just the critical paths, and all other stuff is just fixed as ASAP as possible. Of course, to start this way, you need to have good unit tests, because without unit tests, you are just releasing something to production, and you don't know what's the quality of this software. And we want to fix ASAP, but not fix like 10 times a day. Okay? So good unit tests will prevent you in fixing too often. Okay, now let's move to the other stuff, the performance. Everyone said that microservices are awesome. We are going to the business and we are saying, hey, the business, please give us the money, we'll split this monolith into microservices and it will be awesome. It will be faster, it will be better, and everything will be great. That's, of course, not true. When you split the monolith into microservices, it will get much more slower. Why? Because there will be giant communication overhead. Okay? Serializing and deserializing, sending objects, sending JSONs over the network, logging requests and response, it all takes time. So, okay, that's the problem, but let's run performance tests to be sure that it's not bad and it's not worse than in the monolith. But the performance tests are expensive, are inaccurate, and they're tricky, okay? There are a lot of ways that you can fail doing the performance test, okay? There is giant knowledge about how to test the JVM applications, test the performance, because you need to remember about warm-up, you need to remember about different branches, okay? About JIT, about the whole JVM infrastructure, and you must take care about the production traffic. And the production traffic is usually on production. Okay? There is no production traffic on stage environment. I can try to record it, but replying this one with the proper peaks, etc., it's a hard thing. So what can I do else to solve this problem? So the monitoring is the new testing. I want to monitor my application on production instead of verifying the performance. But then I can degrade my performance a lot, right? I'm deploying a new version to production and it's 2 times slower, 3 times slower than the other version. That's a problem. But I have a continuous delivery to the rescue, okay? I'm releasing just 10 commits every day, okay? There is still a chance that the 10 commits will degrade the performance a lot, but just a tiny chance. I can deal with this. Okay? So I'm verifying and monitoring all the time on production using tools like, I don't know, New Relic, AppDynamics, Dynatrace, that will tell me, okay, so today this method is taking like 3 milliseconds more than yesterday and the day before, so please take a look at this one. Okay? The problem with monitoring is that we usually use statistics to describe what's happening in our application. And when you take a look at something that is called the Scum quartet, these are 4 different data sets that have exactly the same simple descriptive statistics. So the mean of X is the same in all 4 ideas. Sample variance, okay, correlation, linear regression, mean of Y, it's the same of all for all 4 data sets. But if we consider that it's, for example, the response time versus the number of users, there is a giant difference between those charts, okay? So statistics is lying to us all the time. So thinking about the average response time makes totally no sense, okay? It won't bring us closer to creating something that's maintainable. So what can we do? We can use percentiles. What is a percentile? The P90 tells us that the 90% of the requests, for example, are finishing in desired time. P99 tells us that the 99% of samples are following some requirements, okay? But there are a lot of percentiles, and which percentiles should I care about? P95, P99, maybe 99.5, okay? Which percentile is important for us? And the funny thing is that when you consider that you have 10, you need to make 10 requests to be able to render the page. So P90 says that in the worst case, there is 100% chance that this page will load slower than we expected. Why? Because I'm just taking care about P90, so about the 90% of all requests, okay? And the problem is that usually in my applications, it's not just that all requests are following the same times. There is usually one slow request for the page. So I'm loading the page, I'm hitting 10 requests, and one is loading the giant amount of data from some dictionary services. And it takes like 30 seconds to complete. And I'm saying that 90% of the requests must finish in 1 second. Okay, so 9 requests are finishing in 1 second, but the last is taking 30 seconds, okay? So that's the problem. With P95, I have like 50% chance, in the worst case, that my page will load slower than I expected. And what's the problem? The problem is that even if you think about the P99, then I have more than one page load for the whole session. So it means that for P99, when I just try to get 99% of my requests to stick to the following rules, then for 10 pages per session and 10 requests per page, it means that in worst case, I will have 100% frustrated users, which is not good for our business, okay? So in practice, we need to monitor and we need to take care about the P99.9 or 99.95. That's the stuff that you want to verify. That's the stuff that you want to take care about, okay? So I'm taking care about mostly 100% of my requests. And to be honest, it's really hard, it's extremely hard to take care about the percentile 99.95 because there are garbage collection issues, caches, network latencies, some communication problems, okay? And what's even more complicated is when you want to give the business the SLA of the P99.95, then you must monitor something else because you need to check what's just around the corner. Maybe there is a hockey stick around the corner, okay? And just increasing the load of the application for few percent will degrade the performance 3 times. That's possible because we are hitting the wall. And we must also remember about that. Okay? Another thing that I want to cover is something that's called automation. Why? Because there is an issue that comes with the scale of the microservices. When you have 10 servers on production or 20 servers on production, it's pretty easy to upgrade the JVM on all servers. You just need to SSH to the server and do some actions to update the Java, okay? But what happens when you have the hundreds of servers? Are you going to SSH to all servers? Of course not. So we must automate the stuff. I need to have some robots, okay, or demos that will be able to do this stuff for me. The hard thing is that when you have hundreds of servers and each server is maintained in the other way, there is no way to automate this one. So the first thing I must remember is the approach that is called the convention over configuration. What does it mean? I don't want to configure anything. I want to have strong conventions. What does it mean? For example, it means that if you have a service that is called the builder, okay? What are the conventions over here? Okay, so the artifact ID for this server is also a builder. The name of the jar is a builder.jar. It lives in a target/builder.jar, okay? The name of this service in the service discovery, it's a builder. The name of the user that it runs on production, it's a builder, okay? The localizations of log is /user/builder/log/service.log or something like this. I'm bringing the strong conventions. And then I can change the projects. And I know how they are created, how they are designed, because everything is run by convention. Do you want to find a VM that this service runs on production, no problem. It will be, for example, builder 1, builder 2, builder 3. That's the convention. What's the name of the load balancer for this platform? Okay, so it's load balancer minus builder 1 or something like this. Okay, that's the convention. I don't need to configure anything. When I'm provisioning the virtual machine, I don't need to say if this virtual machine must use a load balancer or not. Is there a load balancer with proper name? Yes, so use it. It's created for you. Okay? That's the convention over configuration. That's something that allows you to keep even the giant infrastructure using just few people and good scripts. Okay? Because there is no configuration. You are building the configuration at runtime using the conventions. Okay? And what does it mean that I must automate anything? It means that everything is a code. Okay? What does it mean pipeline is a code? When you have a lot of jobs on Jenkins, then you don't want to say, okay, so I need to add one profile to the build job. Okay, I will just open 10,000 jobs and click on them. No, you won't. Okay? The Jenkins jobs must be created from some place. This place is a pipeline as a code. So I'm, for example, using job DSL for Jenkins, when I can generate all the jobs automatically. If you need to add a profile to the deployment jobs, then you add it in one place, you recreate all the jobs, and you are done. Okay? What is also cool in this one, should I back up my Jenkins or not anymore? I don't need to back up my Jenkins because I'm able to recreate the whole Jenkins instance with all jobs in a few minutes. Because Jenkins is not longer a master of my jobs. The master of my jobs is job DSL that lives in some Git repository on some server, okay? So the only thing I need to back up is my Git repository. The same applies to infrastructure, okay? When I'm able to set up a virtual machine, when I'm able to set up a load balancer, network interfaces, drives, etc., which is extremely easy when you use the cloud. So we, for example, are using the Azure cloud, and we are using the Java SDK provided by Microsoft to create and provision the infrastructure. So do I need to back up my infrastructure? No, because I'm able to recreate the whole Devskiller platform in 1 hour. I will just need to execute one command, and this one command will create everything for me. Okay? What's with the configuration of those virtual machines? So I'm using Ansible, and Ansible is taking care about bringing this virtual machine into the correct state. What's the correct state? It means that the Java is installed here in the proper version, that there are packages and dependencies in the proper version, there are proper users, so proper groups, configuration for logback, configuration of the services, etc., etc., etc. Monitoring is set up, etc. Okay? And then, do I need to back up this virtual machine? No, because if this virtual machine exploded and just gone, I'm able to create it in like 5 minutes. Okay? So it means no backup at all. I just need to back up my data. Not configuration, no infrastructure, no nothing. There is also no way to introduce manual changes. So I have great audit of my whole infrastructure. I know why someone has installed this dependency, why someone has updated such dependency. Because how can you update, for example, Docker on production? You need to change the repository with the configuration pipelines, okay? So with the Ansible playbooks, and you say, okay, so now please install Docker in version, I don't know, 1.12 instead of 1.11. And I'm committing it in some context. And if something breaks down, you know, okay, so Jacob, why did you change this version? Okay? Because I know who made this change, because everything is versioned and auditable because I'm using Git. The same applies to the configuration, okay? I have a configuration as a code. I have everything as a code, to be honest, okay? So all my application properties, all configuration, passwords, etc., lives in the repository. I know why someone has changed the flag. Why did you change the garbage collector configuration? When and how, etc. Everything is in the code. And that means I'm able to analyze all changes in my service. Okay? And thanks to this approach, it's really easy to maintain the software, okay? Because everything is, there is nothing that will go, okay? There is no knowledge that will go. I know how to build this service because this information is stored in the repository. I can store it on Wiki, okay, on the Wiki page. But how can you be sure that it's up to date? And I know that my Jenkins jobs are up to date because I'm using them all the time to build the software. How do you know that the application properties or the passwords stored somewhere are up to date? I know because I'm creating and setting up my system based on this configuration. So it needs to be up to date because otherwise my production service won't work. Okay? So that's the way. I'm enforcing that everything is up to date because I'm setting up my service based on that. I can, of course, describe, hey, if you want to set up your service, please be sure to create such users, such groups, such directory structure, etc. Okay, I can write that. But if someone says, okay, we need another user, but forget to put it on the wiki page, then I'm screwed. And if you forget to put it into the ANSI playbooks, then you are screwed because it's not working on production. There is no other way to introduce anything to the production than going through this code. Okay? And I hope that this knowledge will be enough to don't read this book in few years. Because a few years ago, everyone was talking that the microservices are cool. They are a solution for every issue on the planet. Okay? People won't be hungry anymore because we have microservices. And that's, of course, not true. Microservices are the most complicated architecture that I ever used. But they, are, of course, have giant potential. And when you want to follow these principles I described, then you will be successful in living with microservices on a production, not just in using microservices on your laptop as some simple tutorial. Okay, thank you very much. Do you have any questions? Okay, if there will be any questions, I will be here for a few minutes, so please don't be afraid. Thank you very much.